Hello everyone, welcome to this session number 11 on Introduction to Statistics, visualizing data with charts and graphs. So in this session number 11, we'll be focusing on the quantitative data, how to represent the quantitative data in the form of histograms. Okay, so this is a part 1 and yeah, so this is about me and my LinkedIn ID is this. You can follow on LinkedIn and you can ask anything if you wanted to ask, right? Yeah, so these are all the ways primarily we have to organize the data: quantitative data and qualitative data and numerical. So in the previous sessions we are done with the qualitative data. If anyone miss, please visit my channel. There you will find all the videos related to pie charts, bar graphs, Pareto charts. And then we move to numerical data. In that we are done with the tally marks and frequency distributions. As I said, there are two types. One is discrete, the other one is continuous. And then we are already learned how to convert this discrete to continuous class intervals because of importance of the continuous class intervals. Okay, so these scatter plots and time series graphs, I'll make the videos on these two later. Okay, so in this session our focus will be histograms. Okay. Yeah, so histograms are nothing but they are also a form of representation like bar graphs, right? But the only difference is histograms are used to represent the data, which is of grouped frequency distribution with continuous classes, right? If you observe in the bar graphs, we have bars like a rectangular bars, and this is the way, right? We did represented the bar graphs data in the form of bar graphs. If you observe, so there is a gap between two consecutive bars in the bar graphs, but here you don't find any. Why? Because this data is continuous classes, right? For example, if I want to write to the classes, it is starting from 300 to 400, the first bar, and the second bar is a 400 to 500, this one, and the next one is a 500 to 600 and so on. So if you see, these are all continuous classes. Clear? And now look at the second one. So what is the first class here? 0 to 40. And then second one, this one, 40 to 80. And this is 80 to 100. And this is 100 to 180. Right? So that is the one difference. The first difference is this is only for continuous class interval data, right? Obviously when you have a group of data, we use either discrete or continuous, but to draw the histograms we should make the class intervals as continuous, then only we can draw the histograms. Clear? And the second thing is, one more thing you should keep it in mind is that these histograms can be of two types. One is with same width of the bars are all equal, or the width of the bars are varying. You can see here in this is the first one, first histogram. If you see here, the gap between them 300 to 400, right? So 300 to 400, what is the width here? 100. And 400 to 500, what is the width here? 100. So that is the first one. Now look at the second one. The first interval is 0 to 40. The second one is a 40 to 80. And then we have 80 to 100. Then we have 100 to 180. Now look at here. What is the width here? 40. Here also width 40. But here look at the width. What is the width here? 20. and here look at the width here. So here the width are varying and here width are same. So whether it is of the first kind or the second kind of histograms, you should always make sure that the area of each rectangular bars should be proportional to the frequency. So that is the one thing we should keep it in mind while drawing the histograms, right? So I'll make a session on that, like by taking the different width how to draw and whether the drawn histogram is correctly representing the data or not, how to check whether whatever the histogram we have drawn is it a correct representation of the given data or not, that I will show you in the next upcoming sessions. Okay, so obviously here if width are same, right, if width are same, then obviously the length is directly proportional to the frequency, right? If a width are different, we should make sure that the areas, the area of each bar should be proportional to the frequency. So that is the one thing you should keep it in mind. Clear? So again, so these histograms are nothing but a representation of the bar graphs. The only difference between the bar graphs and histogram is that in bar graphs we maintain the uniform gap between the consecutive rectangular bars. Here we don't maintain. So these are all the continuous classes. Clear? So these histograms we use in varieties of ways we can use, especially if you want to find what is the which kind of distribution it is. So in the upcoming sessions I will be making the videos when you move to the higher level of statistics. So there you will find that there are different types of distributions are there. Okay, so to understand which kind of distribution it is that, so we just draw the histograms and then we see if the histogram type the is of this kind, then it is a normal distribution. And if it is starting from the left to right increasing, then it is a left skewed distribution. And then if it is coming from the right to left, then it is a right skewed distribution. And then almost if they are coming in the uniform way, right, so then it is a uniform distribution, then binomial distribution, then multi-modal distribution. So these are all the things we will be learning in the next coming sessions. Okay, so these are all the ways we can use histograms to identify which kind of distribution it is. Okay, yeah, so thank you for yeah, that's all for today's session. Okay, thank you.